Hi, everybody. My name is Zach Fejes, as it may in fact say on wherever the little thing posting about this session is. I am the team lead of the Voice Lab, a small research and development unit within the Royal Bank of Canada. We are Canada's largest financial institution. I've been a member of the team for about a year and a half now. I was brought on as a developer when we started the team back in November 2018. And as positions shuffled around a little bit, I gained some more managerial responsibility, and right now I'm leading development on the team. So we have a lot of very cool work we get to touch, interact with, and we do it from the perspective of a very large, technically capable company with a lot of resources. And this means that we have a lot of opportunity to break new ground with technologies, but also leverage technologies in a way that affects millions upon millions of people and communities that we serve all across the country, but we're more than a purely Canadian bank, all across the globe. In my time, about a year and a half at RBC as part of this team, I've had the opportunity to meet a lot of brilliant people in the voice space from all over the world. I've had the opportunity to work with an absolutely amazing team within RBC, and we've had the great chance to work on some really interesting problems. Even during this global crisis time, we're having new and sort of unprecedented opportunity to make an impact on the lives of our clients and the communities we serve. And from that year of experience in the voice space, I've come to a couple of conclusions about where I think voice as a technology is going, how useful I see it being in the future. Hint, it's very. But more than that, I mean, that's why you're here today, but more than that, I see there being a new wave of interface design, conception, that goes well beyond just voice interfaces, or even beyond what we usually refer to as multimodal or mixed interfaces. I think that in reality, what's going to be changing the game for technologies in the next 10 years, 20 years even, is truly parallel interfaces. That is to say, interfaces that access the same services, leverage those services, but allow users to traverse journeys between the interfaces, between the channels of engagement. If you're a more traditional business or you work with one, you might be more familiar with that term, the channel of engagement. And I think my team has found over the past year that that is really the way that not only the technology is moving, but that will help businesses advance the most quickly and the most profitably over time, because it allows them to engage their clients more effectively. Now, I believe this strongly, and I believe that a good problem-solving mindset is key to almost everything. In a technical profession, in a business profession, in a marketing or an arts profession, problem solving is everything. My training, my background is in electrical engineering, and I got into software development after leaving school because A, lot of opportunities in software development, but B, because you can solve very different types of problems. And I found I liked the types of problems we're solving. Now, this conception of using parallel interfaces to solve any given problem has some additional benefits, and we're going to be talking about that. And I think now's a great time to pop up this slide, because today we're going to be talking not only about how to solve a given problem, but how to use this conception to better break down and solve every problem. Now, this is a huge statement. I get that. And I also get that it's a little over the top, but I'm trying to drive home a point here, which is that by the end of this session, what I want to leave you all with is some additional tools in your problem-solving tool set, specifically the tools that let you look at a problem, whether it's a technical or a business problem, and break down what channels of engagement are ideal to use to solve that problem, to engage with your clients, your businesses, effectively your own team, anybody who's involved, any stakeholder in your circle, you can better understand and better solve problems for, which is why I call this talk Solving Every Problem, because at the end of the day, all you need to solve every problem is a better and better tool set. And right now, the tools afforded to us by this more recent wave of development in voice, in cognitive services in general, is creating new opportunities that all of us are excited about. I mean, why else would you be joining us for a 24-hour live stream about them? It's amazing. And I think that the ability to talk about them, the ability to discuss and better understand these problems makes it so much more exciting when we have an open community. And again, that's what I've found for the past year and a half, and that's what I want to pay forward, both as a representative of my organization, but also just as an individual sort of technical worker. I want to be able to help people better understand how to solve problems, because at the end of the day, it's not one of us who solves everything, it's all of us working to common goals and common ends. And that's exciting. So let's stop for a moment and talk a little bit about the types of interfaces we might be looking at today based on what's available. So I'm going to spin up a slide, magic. So here you see a whole bunch of interfaces listed. Now, most of you are probably familiar with a good number of these, but I've gone out of my way to include a couple here that you may not be familiar with, or if you are, you've never really thought of as core channels of engagement. But I want to leave them up there, and I want to give you a better idea of why they're there. And we'll get to that over time, and it'll make a little bit more sense as we go along here. But let me highlight a couple of key ones that are on this slide that we're going to be talking about today. First of all, you have web interfaces. Now, these usually, in my definition at least, are visual first interfaces. This includes things like screens. And screens have the ability to output images, output text. You can interact with them in an output manner. That's usually what they're for. Web also, however, has inputs. Now, they can be driven by different things, and we're not going to talk about that within this. Specifically, web is about that visual framework with a fair bit of square footage. Specifically, web interfaces focus on visuals. That is, larger scale visuals when you have a fair bit of real estate to work with, a screen, and the user can interact with your service through that. That is our first channel of engagement. We're going to be talking about web. The second channel of engagement we're going to talk about is, surprise, voice. Now, this channel on its own doesn't have visuals associated with it. We can tie them together, but again, for the sake of this conversation, let's just say voice is its own thing. And that includes, from an input-output perspective, that includes microphones in. It could be a single microphone, as is the case with my laptop or my mobile phone, or it could be a microphone array, be it a phased array or otherwise, that you might find in a smart speaker, or you might find in the more modern smart home hubs, or different IoT systems. There's lots of versions of them. There's lots of different architectures and hardware solutions for that, but effectively voice comes down to audio in and out. And then finally, there's a fourth category that I'm going to effectively bucket other things into because they're a little more niche, but they're solutions usually for people who have accessibility concerns. And those will be a little more specific to the individual case, but it could be to help people with motor control issues. It could be to help people who actually have minimal use of either hearing or sight. And these solutions, not only should they not be ignored, but I think it's important to view them in this same matrix because it's going to help us look at problems a little differently. The next interface I want to bring up is mobile. And I'm bringing this up separate of web for a couple of reasons. Now, mobile interfaces are similar to web. They have a certain amount of real estate that is visual. However, it's usually much smaller than web. I think we can all agree on that. But secondarily, mobile also has built-in now, at least with smartphones, built-in touch capability, a little bit of haptic feedback. And those create different circumstances than for a traditional web on, let's say, a computer or a desktop, laptop. And apps themselves provide a slightly different channel to engage with. So I want to keep mobile on its own for this analysis because, again, when we break down problems and we talk about how to assess them and what the right channel is and how to leverage multiple channels for the same thing, we're going to be separating those things. So that's mobile. The next thing we have to ask is, for any of these given interfaces, what are they good at and what are they garbage at? And I think we have to be honest with ourselves in that too, because it's common in technology fields, especially when we're passionate about certain technologies, as I'm sure the vast majority of us are. It's very easy to push aside any of the failings and say, yeah, but we're working on that. We're getting there. I actually think it's critically important to embrace those weaknesses because it correctly tells you how to address a given problem. Let me give you a practical example. Have you ever tried to describe a graph to someone? It's not super easy. You can describe general trends over time, like if there is a downward sloping trend or an upward exponential curve. You can use some common terminology to convey the idea. But if they're complicated graphs, if they have a lot of data, if it's dense and needs unpacking, describing it verbally is really difficult. At least in my experience and the experience of people I've talked to about this, most people would much prefer to have an image to show them, a diagram, effectively, the graph itself. And I think that's fair because the old adage, a picture says 1,000 words, is very true. Images are, by definition, really, really good at conveying dense information because it abstracts them. It abstracts them into different types of imagery, into potentially lettering, but our brains are great at taking that really dense information and breaking it apart to derive meaning. For that reason, visual interfaces are, generally speaking, fantastic at giving us, from an output perspective, incredibly dense amounts of information. Now, again, there's optimizations within that, and the types of information matter, but as a general rule, for our own analysis and for the analysis of today, let's look at visual interfaces as really great output systems. On the flip side, from an input perspective, how do we input information into, let's say, a web browser? If we're talking about web, let's keep talking about web. So in a web browser, traditionally, we would use something like forums, right? We'd do form filling. We'd enter our email address, we'd enter a password, or we'd enter all the information to make an order off of our favorite web shopping platform. We would do those things and we'd enter that information in a way that is ideal for the computer to interpret it. We're taking out as much of the variability of the input as we can so that the computer doesn't have trouble, or the end service, really, doesn't have trouble analyzing that information. Now, that's good and fine. It takes a little bit of time. You have to get very used to that way of inputting this information. And there isn't really standard between different organizations. There's some trends that have emerged over time. But generally speaking, if you see one form, there's no reason it looks the same as another. And one way or another, you can't put in your information in a way that is, let's say, honest the way you would describe it. You really have to bullet down to what they're doing. I don't know about you guys, but I certainly get form filling fatigue all the time. When I'm using new services or using different sites, I hate it. I think it's such a archaic way of inputting information because, again, we're kind of censoring ourselves with that information, and that's not necessary. That's a workaround. And in my mind, a workaround is effectively a way to highlight that there is an underlying weakness in this case, in this technology. So that in mind, I think it's fair to say for web, we have really, really great information-dense output, and we have okay informational input. It's what we've been using, right? So that's web. Now let's look at the second of these technologies, mobile. Mobile has a slightly smaller amount of real estate than the web, at least on a desktop or a laptop sense. It has smaller real estate, which means that the amount of information you can convey via pictures is less. Fair assessment? Fair assessment. I think it's reasonable to say. And on top of that, form filling gets much more frustrating when your form factor for the phone is smaller. It's harder to input information. God knows I have bigger hands, so maybe it's me, but practically speaking, I think it's a lot of us who really don't like filling out forms on mobile devices. It's frustrating, and it effectively just amplifies some of the problems that you see on the web. So I'd say phones are very similar in that way. Now, there are a few benefits to mobile devices that the web doesn't have. The easiest one is it is portable. In traditional computing on laptops and desktop computers, you obviously can't really carry around that all the time. The ability to take something out immediately and have it at your fingertips is something that mobile has, that web does not, at least not in that interface method. And I think that's worth mentioning because that is a huge benefit to that technology. The other benefit to mobile is that usually it's integrated with a number of other services, be them telephony, be they apps that you can download and change. That's much like other computers. However, again, the ease and quickness of interaction is a huge boon. So there's benefits there. But again, one of the biggest difficulties on mobile is also the input density is low. Again, if we're just talking about information density, it's low. And that's, again, a bit of a problem. But this, I think, brings me to my favorite part of this, which is, why is voice important? Voice is, in many ways, a fundamentally different interface method, in that it, by the very way it works nowadays, involves a machine learning process, involves natural language understanding, involves the expectation that in any given service, it's going to have to parse what you say and interpret and understand it. Unlike more traditional interfaces, where the onus is both on the user to frame their queries or frame their inputs correctly, or it's on the businesses to create a good enough validation system that it makes the user frame their stuff correctly. None of that is natural. And on top of that, it's very information light or sparse, because again, you want to break up the information as much as possible on those channels of engagement so that you can accurately interpret them without any problems. With voice, it doesn't work that way. With voice, you can input incredibly dense information, not only because you can speak and an interpretation process is expected to take the next step for you, but it's even more than that. Audio from the spoken voice contains an incredibly dense amount of information. Not only am I saying something, what I'm saying carries with it context, it carries decisions in the words I've chosen, which implies things about mood, implies things about background, additional pieces of context, and the prosody of my speech, the attributes that aren't the word I've chosen, things like tone and pitch and rate. Those things are fantastic indicators of emotion, of intent, and of feeling at any given time. And that itself is an important contextual cue that, again, with that information being captured, we can provide much better responses as a service for any problem we're facing. So voice is fantastic at taking in information that is really dense. And that's something that the other interfaces we've talked about are not that good at. We have workarounds for it. And that's what I think has changed the game a little bit. And that's why so many of us are excited about voice. It's in many ways fundamentally different. And more, the services that are used to make voice possible at scale have fundamentally different expectations of, that is to say, they expect to parse the intent of complex information instead of taking a single line. And that opens up a whole new world of possibilities. Now, I'd be remiss if I didn't heed my own earlier advice and say, what are the downsides of voice? What are the weaknesses of this technology and this channel of engagement? And I think the answer to that is that voice, unlike visual interfaces, is not great at conveying dense information out, at least not yet. And let me kind of explain what I mean by that. When you were trying to describe that graph earlier in my example, you're limited by the type of context you can rely on with the other person. Has that person seen this type of trend before? If I say it's a downward trend, I have to assume they have if I want to use that language. Do they know what an exponential is? That they may not. And I have to, again, preface with that context sharing. I have to make sure they understand it. That's a lot of information necessary to even start providing an answer to their question. So there's limits to how dense you can get information going outbound on a voice channel right now. Down the road, it may be possible to increase the density of that by including better simulation of empathy, better simulation of emotional response, because then we can carry emotional content, be it simulated, but we can carry appropriate emotional content on the voice outbound part of the channel. But again, there are limitations to that. And I think it's really important to recognize that, because that brings us back to our chart from the beginning. Now, looking at this, we've filled this out a little bit together to explain what each interface is, what it's good at, and what it's weak at. And this brings us to the critical part of today's talk, which is, how do we solve problems with this? My answer is, for any given problem, we should be looking at this matrix. We should be assessing our problem through the lens of these technologies and asking ourselves, what makes the most sense for what we're trying to do? All of these technologies are common enough now that the users are there. I think it's incumbent upon us as businesses, as technologists, as developers, as advocates, to look at each of these technologies with a very honest eye and say, what's the best one for what I want to achieve? Let's look at another example together. I love examples. I love problem solving. So let's look at one together. Let's say I want to create a brand new service. It's awesome. It's a space company, and it's focused around launching astronauts to the International Space Station aboard a reusable rocket. Doesn't sound familiar, right? No, nobody's heard of anything like that in recent years, recent days, recent hours. So no problem. We have this brand new system. Now, throughout the flight, we know that the astronauts are going to be on their rocket. They're going to be strapped into their seats. For anybody who watched the launch, I think it was last week, it was a really impressive flight, and you saw that SpaceX actually worked on some really pretty interfaces. When you see them compared to the old shuttle or the Soyuz interfaces, it's night and day. But I think they require a little bit of analysis. And I think it's, again, very useful for us to look at this case. So we have our visual interface. Now, if I'm an astronaut, I'm strapped in my seat. I want to be able to touch things really quickly. Well, my suit has gloves that have a little bit of conduction at the fingertips, so good, I can use the touch interface. That makes my input and feedback a lot more visual. All of my space can be visual information. One of the benefits, again, of touch interfaces is all of the real estate of the screen is for visible output, as well as input. I'm not taking part of the console for a keyboard, right? So there's a benefit to that. We're maximizing visual and information output, which for a space capsule is a big deal. You want to know where you're going, and you want a lot of information at your fingertips. So that's great. The other thing I think we should notice about this is what their flight path is going to be. Now, for those of you who know a little bit about rocketry or a little bit about space physics, you know that to get off the planet takes a lot of energy. And that lot of energy comes in the form of a really, really big, if directed, explosion. Now, there are effectively two guys, in this case it was Bob and Doug, but there are two guys who are strapped to a gigantic rocket who are going to be shooting into space. And long and short of it is, for the first few minutes of that, they are going to be under incredible G-force. I also think it's fair to say that the first few minutes of that flight are in many ways the most critical. They are when the forces that the rocket is under are the highest. There are many stresses acting on the system, and frankly, everybody is trying to make sure it goes well, which means everybody's tension is high too. There's a lot going on there. Now, on top of that, the physics of the situation means that the astronauts are pushed back in their seats. So suddenly I am going to have a lot more trouble touching that touch screen. Right? If I'm suddenly limited in my way to interact with that interface, I can't use it for what it's worth. I have to rely on it to know what I need. But your voice isn't limited in that way. Not only that, but you have microphones in your helmet. So again, this is another opportunity where you can say, well, maybe it's worth building a parallel interface. Because for those instances where we're under high gravity, which again, we expect to happen in this system, we need to be able to capture real and detailed input from our users about what they want and be able to display it back on the interface. Now, this sounds a little bit like a classic multimodal example, right? We have voice and we have visuals. But I think what's important here is that when we're talking about this, we understand that it's about being able to do all of the things you could, in theory, do with visuals, with voice. And this is where it gets powerful, because even if there are weaknesses in some spots, like let's say form filling, there are weaknesses in form filling on visuals. In voice, there's weaknesses in output. If we build systems that are in many ways redundant, and I know for an engineer that's a bad term. You're like, oh man, you don't want to add a lot of extra to what you're doing. You want to barely build the bridge. That's why you're an engineer. Good call, except I think especially in recent months, we've seen what having a hyper-efficient pipeline does for a lot of our industry. We don't keep ourselves resilient. And I think, especially when we're talking about customers, clients, businesses, communities, we have to think resiliently. We have to think, what is going to provide the best service for our clients, regardless of what's about to happen, regardless of what does happen, and regardless of the changing needs of our clients? How do we always provide that best service? And I think the answer is creating these redundant systems. So, for example, if we are building that spaceship with a brand new interface, my first thought would be, well, let's generalize the systems. Anything they need that provides information, anything they need that takes input to create control systems or to, let's say, guide control systems. All of those things are services on the back end, if you want to look at it from a traditional programming sense. They're back-end services. They interface with the hardware. Now, the front-end services, the channels of engagement, are visual, are voice. But since you know what the back-end is, you could treat it in many ways like a REST API and simply say, there's a whole bunch of services we can offer, create the interfaces for each of them. And then it's a business decision to say, which of those interfaces do we create first? What are our priorities here? But how do we manage this with web interfaces, with audio, voice interfaces? How do we handle this with additional interfaces, like tactile interfaces? How do we do this on mobile? Just like companies traditionally said, oh, we need an app. Well, I don't think everybody should jump the gun on that, whether it's for voice or for mobile or for web. I think the correct way to look at any problem is looking at it through the lens of what do you need to achieve? Do you have a service that is high information density output? Yes, you need a visual interface. Just you do. That's where you should go first. Do you have a system that requires a ton of information from a user? And is it nuanced? Is it something that you necessarily know right off the bat the form it's going to take? No? Then why aren't you using voice? The entire goal of voice technology is to analyze intent. And that's what you want to do with that information. You wonder why call systems are so effective. All these years is because they're taking, in many ways, unstructured information and working to understand and structure it. And that's a huge deal because that's available at our fingertips now. The technology is there to support us in that. That's so exciting because it lets us solve any problem and every problem. And then further, if we look at issues of accessibility, which in my mind is one of the most important things we need to look at as technologists with a much more open and empathetic eye, the more systems we have working in parallel, or the more interfaces or channels of engagement we have working in parallel that give access to the same services, the more we can reliably support all of our clients, all of our employees, if these are in-facing tools, all of our communities, depending on what type of business we work in. It allows us to say, you know what, we got you, don't worry. Even if we know that visual input isn't the best for this system, it's available, it's there. Because again, the service is there in the back end. It's one of the most exciting things. Solving problems in this way lets us prioritize how we build things. We can decide which interface we want to build first and why. It lets us parameterize the utility of them. Let's say we have specific KPIs. We want to get a certain number of people using the platform. This type of metric, which I'm going to leave you with today, can effectively provide you the means to look at the problem and say, well, we know this is the type of data we want the users to have. That means they're going to need visuals. That means we're going to be sticking with web or mobile for now. Are they hyper-dense visuals? We're going to be sticking with web. Is this a service that's needed in transit, on the go? Probably mobile. Do they have to input a lot of information? Oh, we need to start talking about voice. That's a good conversation to be having, and I think that's how we need to start addressing these problems. So guys, thank you so much for joining me for today's talk. I had a lot of fun with it. I hope you did too. And I know I've been down in the live Q&A session this whole time, hopefully answering some good questions for you. But you should always feel welcome to reach out to me. I've included my email below, but also my contact information is in the thing. Guys, have a lovely day. Stay safe. Cheers.